Math 70, section 6.5. 6.5 is basically a review of 6.1 to 6.4. You have to be able to take a polynomial and be able to use one of the techniques that we've learned in 6.1 to 6.4 and be able to factor it completely. So here, I sent you these notes. The first thing you're going to want to do is make sure the greatest common factor is factored out. Always look to see if there's something common. That's very, very important. Then you're going to want to count the number of terms. If there's two terms, then it's maybe the difference of two perfect squares, or it's a perfect square trinomial. If it's a perfect square trinomial, you want to look for the first and the third term to see if they're perfect squares. And if it's a quadratic trinomial, you want to see if the leading coefficient is a 1, or if it's a 1, then you can ask yourself what times what is this, but adds to be the middle term. If it's not a 1, you're going to either use the factoring by grouping method or the trial and error. And then if there's 4 terms, you will factor by grouping. Those are the four different steps that you are going to do. So here, this is just a review of all the different types of factoring. So let's look at these examples a little closely. So for the first example, I see a trinomial, and I see the fact that there is a common factor of 2 in the midst here. So if I pull that 2 out, I end up with x squared minus 2x minus 24. So I GCF'd a 2. Now the leading coefficient here is 1. So now I'm going to ask myself, what times what? I know this is x times x. What times what is negative 24, but adds to be negative 2? So I want to look at terms. So I know that 6 times 4 is 24. So if I make the 6 a negative and the 4 a positive, that will make it where it's the product is negative 24 and the sum is negative 2. Okay. So, example 2. Hang on. Okay, so the second example, let's look to see that you can factor any GCF out, and you can't. I have a 12 and a 5 and a negative 3. There's nothing common. So this one, I'm going to want to try to either factor by trial and error, or I can do the product method. So let's do the A times C. So 12 times 3 is 36. A times C. 12 times 3 is 36. So I want two numbers that multiply to give me 36, but are going to add to be 5. So let's see, what number? So 4 times 9 is 36. And this would, if I make one a positive, one a negative, which I'm going to need, so we're going to make it a 4 and 9. So it's going to be 12p squared. We're going to make it minus 4p plus 9p minus 3, because these two add to be 5p. So now take the first two, take out a 4p, and you're left with 3p minus 1. These two take out a 3, you're left with 3p minus 1. And then the 3p minus 1 is common to both of these, and you're left with 4p plus 3. Okay? Example 3. Okay, example 3. We are looking at this closely, and right away I see a common factor. I see a 3. We could take a 3 out of these 3. That GCF a 3 out. So if I pull a 3 out, I'm left with 4x squared plus 12xy plus 9y squared. Now I notice that these two are perfect squares. This is 2x times 2x, and this is 3y times 3y. And if I multiply one of each of these times 2, I do get that middle term. So this will be 3 times 2x, remember you take this sign, plus 3y, and since there's two of them, you can abbreviate it as 3 times 2x plus 3y quantity squared. So this one was a combination of GCF and perfect square trinomial. Okay, next one. This one looks like I can take out something common. Let me get some paper. So it looks like we could take out a 2. A 2 is common, and I'm counting the number of terms. So it says 16m to the third plus 54. If I take a 2 out, I get 8m cubed plus 27. Now this is a 2m, 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 and this is 3 times 3 times 3. So we bring this 2 down, and it's a perfect, the sum of two perfect cubes. So remember, one of each of these goes in the binomial, and whatever this sign is goes here. These two get multiplied. Switch the sign, multiply these two. This sign is always a plus sign. 3 times 3 is 9. Okay. Example 5. We are going to, for this one, pull out a, let's see, looks like a negative 5x. I'm going to take out a negative 5x, and if I take out a negative 5x, I'm going to get x to the 4th power minus 5 goes into 80 16 times. Okay, now let's double check. This times this is 5x to the 5th. This times this is positive 80x. So now this is x squared, and this is 4 times 4. So this is the difference of two perfect squares. So negative 5x goes outside, and then we have x squared minus 4, x squared plus 4. Now this, I notice, can be factored more. This is x minus 2, x plus 2. So this piece is factored more. This is another difference of two perfect squares. Okay, so that's a big one right there. And the last one, this one looks like factoring by grouping. And it looks like there is a 2 we can pull out of all these terms. A GCF of 2 out. If I take a 2 out, I'm left with 2x to the third minus 3x squared minus 18x plus 27. Okay, now I'm counting 4 terms. I'm going to factor by grouping. So that 2 comes out. Here, let's put a bracket here. Okay, so here I'm going to take out x squared. And when I take out x squared, I'm left with 2x minus 3. And then here we can take out a 9, negative 9. Yep. So you're left with 2x minus 3. And here's a hint. You want these to be the same. And it works. Negative 18x times plus 27. So now these two are the same. 2x minus 3 are the same. And then you're left with x squared minus 9. Ooh, this is a tricky one. Bring down that 2. And then here's another kicker for you. That's the difference of two perfect squares. Okay, and everything else comes down except we broke this down further. So again, it's factoring completely. If you stopped right here, this is not broken down as much as it can be. So you really want to make sure you understand all of these different factoring techniques completely, because section 6.6 involves solving equations. So you have to be able to factor them completely before you can solve.